Last time on Jairus, my custom designed Assassin's Creed Hidden Blade came to life. But it's only half done. The extension and retraction worked great, which was a huge hurdle in this project, but it's not the only one. This time we'll see if I can overcome the remaining challenges to make these the greatest hidden blades in the world. Since the last video, I did things. Made holes in the bottom so I could press fit magnets in to keep the blade in place. Painted on some silicone rubber for bumpers, which did two things. It softened the movement so that it doesn't tear itself apart and made it quieter. I also fixed the only leak it had. I made a small aluminum plate that screws on to hold the front seal in place. Now it's time to attach this to me with metal.
Metal.
The goal for these blades is for them to be truly usable. If they were just props, I would only need them to stay on my arm well enough to take pictures with them or maybe walk around a convention. And that is a lot easier than attaching them to withstand a lot of force. And since the blades are based off the idea from the games and not any specific in-game models, I decided to go a little overboard on this part and make all of the parts out of aluminum. And making it with metal will definitely hold it on my arm solid enough for me to use them, because I really want this project to be the most effective, powerful, stealthiest, coolest looking, usable hidden blades ever made. And thank God for Clecos. They're basically through-hole clamps that made this part way easier. They lock in with just a squeeze and hold everything exactly in place, and they're just as easy to remove. They're a colossal time saver. Once I was happy with the shape of all the pieces, I permanently assembled it with real countersunk rivets because they're nice and flat on both sides, and the connection is a lot stronger. To get all the marks off from making and shaping all these parts, I hit it with the wire wheel and gave it a nice even finish. I lined it with craft foam, and now it's ready to go. And with one hand, I can easily latch this onto my arm. I am very pleased with how this came out. It looks really cool and it fits even better. I took a lot of time to shape this aluminum to make sure that it fit nice, and it doesn't even need the foam padding on the inside. It's perfectly comfortable when it's just metal, but I thought that black background would look really cool. I also wanted it to look really good so that it would match with the incredible looking parts that Protolabs hooked me up with for the knife section of this. So huge thank you to them for hooking me up with these parts of this project. And speaking of the knife, it doesn't come out the way it sits right now, so let's fix that. I have a loose idea for the system, and it starts with my pressure source, this CO2 tank. But a liquid CO2 source like that is at 800 psi, which is enough to pop all of the other parts. So before it goes to those, it needs to go through this, a pressure regulator that brings that 800 down to 125 psi. That part only has one tube coming out, and this has two. So to solve that problem, we can use this splitter. Now, if I just hook up those lines, I have pressure on both sides of the knife, and it doesn't go anywhere. So I need to control when pressure goes to each side with these valves. When this valve is turned on, pressure is allowed to flow through. When it's turned off, the pressure is allowed to vent. Now, if I let that 125 psi just go slamming into the piston, it's gonna make the knife go in and out really fast, and it will cause damage. But I need that much pressure to keep the knife out when I'm using it, so I need to adjust the flow, not the pressure. And I can do that with these adjustable flow regulators. And that's the plan in my brain. Time to test, see if it works. All set up and ready to go. Even though these valves don't have any power run to them, they have a button that I can press to make them go. These flow control valves should very accurately control how fast the knife moves in and out. So let's try it. I need to tune the speed of the retract so it goes back in fast enough that when it leaves the seal, the momentum carries it the whole way into the locked position. And I want it to come out fast when it extends, but not so fast that it breaks. Faster. That needs to go faster. That's pretty good. That's not enough. We have a problem. The blade will not go the whole way back in, and this is completely open. So there's only one reason that I can think of, and that's because it's bouncing off a cushion of air that's still inside the back of the piston, which I think means that having this restrictor restricted so the knife blade doesn't come out too fast is restricting the air that's coming back out when this is vented, and I can fix this really quick. If I switch the restrictor to the other side, it will still be restricting the air going in, but the air that's coming out will be unrestricted. With the restrictors switched to the other side, let's try this again. That's pretty good. That's better. That's almost there. There we go. That's the whole way in. That was our problem. This works really well, but I need to automate it. Because you know what they say, can't feed a streaky gopher on a Tuesday. The 3-cell LiPo powers the whole system, which is downregulated to 5 volts by this buck to power the microcontroller, which uses a button press to determine when to switch which relays on and off that then control the valves. Huge thanks to my friends Matt and Hartley for helping me out with the code for this system, because without it, I would have 2 buttons that I would have to very accurately time my presses on. Now I have 1 button, which makes it very easy and very quiet. If I'm running 2 buttons, I press 1 button to make the blade come out. And then I have to hold that button down to keep pressure behind the blade, because when it's released, the pressure vents. And then I press the 2nd button to retract the blade. If I don't time that button press very accurately, it's very loud because of all of the air that's rushing out of the front. With the microcontroller running things, it is a lot quieter. There's no blast of air coming out of the end when the blade retracts. Just like all my other projects, everything for this project is available on my website right now, including the digital files for Protolabs, 3D models for printing, all the templates, the code for the microcontroller, and the parts list. Link below. There's an awful lot of stuff that I have to hide on my body in order to use this. And I could put it all in my pockets if I got very small versions of everything, but that would also make it very expensive. And I could put all of this in a backpack. Most of the characters in the Assassin's Creed games have some type of sack or satchel or pack that they carry, depending on what time period they're from. So it makes sense if I had a backpack, because that's what people use to carry stuff now. But I can't just throw all of the parts in the backpack and have them rattling around. So what I need to do is get all of the stuff mounted and organized on something.
You already did.
Oh yeah, I already did. I didn't want to throw this stuff in just any old bag. I wanted something really special. So I reached out to Solid Gray. It's a small company that makes the coolest backpacks I've ever seen. And when I told them about the project, they thought it was awesome and wanted to be involved. So they hooked me up with one of their hardshell packs. Not only does it look ridiculously cool, but because it's a hardshell pack, it also holds everything tightly in place. To find out more about these unique packs from Solid Gray, I have a link in the description. And now it is time.
Bryce, hook me up.
Stealthy.
All right, first time. That's pretty cool. Obviously this isn't very stealthy, but when I pull the sleeve down it will be, because it'll look like this. Because I made 2. Because Master Assassin. If you were really paying attention, I think you could tell I have something on my arms, but that's pretty stealthy. Is it stealthy? Does that look stealthy? Can you tell that I have knives?
This looks like you got fat forearms.
Yeah. And to activate these things, I made little 3D printed rings that hold a very tiny momentary button that I push on the side. But I'm getting a fair amount of noise from the backpack from the exhaust on the valves, which I can fix by putting mufflers on them and maybe some foam in the backpack to help absorb the noise. The noise out here in my hands is pretty quiet. You know, next to nothing. I'm really happy with how this project turned out, so much so that it definitely needs a standalone video to see how well these actually do when I go to use them. Not sure what I should test them on. Love your input on that. See you next time. Spider-Man.